Okay, here we go right into the second part of the video. Now we're identify if this system of equations has infinitely or no solutions. I want you to know I wrote down the three possibilities down here. Let me explain them a little bit. If the lines are coincident, in other words, if they graph and they're the same line, they just look different up on the system, then that means there's an infinite number of points because they're all the points on the same line. So if it's the same line, you have infinite solutions. If their lines are parallel, like we saw in the first slide, there's no solution. And if any way, shape, or form the lines have different slope, the intersection is going to be one solution. So let's see here. This equation looks like it's ideally set up for substitution. So I'm going to take that y value and plug it in right there. So 4x minus 5. But wait, what is y? Y is that right there. 4/5 x minus 4 in parentheses, and then equals 20. So let's distribute this 5 times here. So 5 times 4/5. Remember, any integer can be written as a fraction, and then you can do some cross-canceling stuff. 4/1 is 4. So 4x, and then minus 4x, that's interesting, plus 20 equals 20. Aha! The 4x's, let me do that in a different color. The 4x's will cancel, and we have the old identity, 20 equals 20. It looks like these are the same line. They're coincident. So you would say resulting in an identity statement, and it has infinite solutions of what you put there. Okay, next question. Now we have to do that same concept. We have to model a system of equations and solve for one of the variables. So always try to use variables to set up to help yourself understand. Let's see, glasses and snack bars. Why don't we use G and B? So 2 glasses plus 3 snack bars have 61 carbs, whereas 4 glasses plus 2 snack bars has 78 carbs. Okay, we're only going to solve this one part way because it's a long problem. Now you have to do some multiplying by different constants and try to get one of these variables set up for elimination. I think what Savas calls the addition method. I'm going to multiply this entire equation times 4. I'm going to multiply this entire equation times -2. That way I can get the g variable. See how I use the opposite constant there, and also I made one of them negative. I want to get the g variable to eliminate. Now watch what happens when you do this. Multiply 4 times all of these constants. Ooh, I hope I can do 4 times 61 in my head. So this is going to be 8g plus 12b equals 244, I hope. And this other one is going to be multiplied by -2, -8g. Aha, look right there. I set up these two variables right here for elimination. -2 times -2b is -4b. And then -2 times 78, I think, equals -156. And then do the elimination method. See, those are going to cancel. You're going to get 8b equals whatever this is, and then solve for b. And then when you get done solving for b, you plug it into one of these equations to solve for the glass of milk, for the carbs there. That's a good explanation of how you do multiplying by a constant or a negative, and then get one of the variables to eliminate using the addition method. Okay, one more question for this video. Kind of the same concept right here, but this time they already have one of the variables is positive and negative. So I'm just going to choose that one so I don't have to multiply by a negative. Multiply by the other constant, 4. Multiply this one by 5, and you're going to get the same thing. 8x plus 20y equals 40. You see how that 4 is multiplying by every single constant in the equation? That's really key that you distribute it all out correctly. Down here you'll have 25x, the minus 20y, and then equals whatever that is. I don't want to do it right now. Let's see what happens. The y's cancel out, and then you'll be left with 33x, why did I choose the highlighter, equals whatever this is, and then you can continue to solve it. Okay? That's the end of this video.